What are isotopes? Let's imagine, right? So example, sodium. In this world, it can, in the form of sodium chloride, sodium iodide, sodium hydroxide. It's all in this world, right? There are many types of sodium atom. They do look a little bit different. Okay? And this is where the definition is. They refers to what? Okay, I start second point first. Together is one line definition. They have the same number of protons. That's a fact. That's why I call them sodium, same element, right? Proton number must be the same number of protons. They have different number of neutrons. So that makes them different really. Everyone okay? I just mentioned they are, I read some space in front, same element. Say sodium element. Yes? What is missing in his answer or their answer? Anyone? Thank you. Because without that, it doesn't mean anything. You ask me where's the keyword? Atoms, same element, same number, protons, different number, neutrons. For 1 mark. And let me explain to you why like that. So basically, because of this effect called the isotopes, all right? So sodium can exist like what? All right? I'll give you an example first, chicken egg issue, right? Later I'll give you more example, okay? So sodium proton number is 11, right? So I have a pink color sodium. Let's say I use different color to show that different, if you don't mind. And I use orange, okay? So hopefully they're a bit different, right? Proton number must be the same, right? Same number of protons. But the number of neutrons is different, and that makes their mass number different. So I don't know what's the actual number. I figured it out, right? So maybe this is 24, and this is 25. I should use pink color. Give me a moment. 24, I call it 25. What color? 24 minus 11 means there is, right, what is this? 25. This clearly shows me there are 25 minus 14, 14 neutrons. And the pink color there clearly shows me there is 13 neutrons. So again, the neutron number is different. This is the concept called isotope. So again, you read my 3 bullet point. Did you explain it? They are the same element, but they are what? They are round one. So it's called atom. They are round one by right. Yes? Because all the simplest way to describe an element is an atom. Okay, make sense, everyone? Now, then we take a look at periodic table. The periodic table, very weird. The periodic table shows me this value, right? 2311. Right? Why? Not 24, not 25. Why 23? Hey, 23. Okay, can I change the value a bit? Like I'm a bit miscue a bit. Okay, don't mind. I change this to, if not, it doesn't make sense, the math. It's basically math. Okay, don't mind. Use the wrong value. Say 22. I need the pink and the green to sandwich the 23. So my bad, okay? But I just want to show you the neutrons different just now. You realize the one in periodic table is what? Is 23 is in between 22 and 25. Everyone okay? So what am I doing? In a periodic table, they only show you one thing. It's called the sodium atom, the sodium element. It represents what? It represents every sodium atoms in this universe. Are you with me, everyone? So what are we doing? In math, we call this what? We take these two, and then what we do? Thank you. It's mathematics. It's averaging effect. Yes? Average. Makes sense what? The periodic table only can talk about sodium. I don't care how many types of sodium you have. There could be more than 2 different isotopes. Could be 3, 4, 5, 6. But I need to have an average to show people the average value. These 3 lines are nobody memorized one. Once you understand what's happening, automatically will come out. So when the proton number same, neutron number is different. Neutron number is different. Obviously, the nucleon, or if not the mass number, is different. Everyone must agree. Okay, first thing. Number 2, the 2 atoms you saw there, sodium, they will have the same chemical properties. What? Because chemical reactions only involve the valence electrons only. Someone, what is called valence electron? Electrons in the where? You learn in Sec 1, Sec 2. In the outermost shell or the valence shell. The most outside one, the shell. If their proton number same, the number of electron must be the same. Make sense? If the electron number is the same, the number of electron in the outer shell must be the same. Make sense? And they are the only one that get involved in chemical reaction. That's it. Keep it simple. This will link to bonding. Does have learned bonding already, right? Slowly. Which they don't explain again in bonding. Next, they have slightly different physical property. Why? Okay, copy this up. Melting point and boiling point normally comes as a set. Else, density. Okay, these are the common physical property. Okay, physical property. Okay, I use density. Everyone know density very well, huh? Okay, density you know very well. Okay, so I draw it out for you. Just now I got sodium. I anyhow just now write 2211. Sodium 2511, right? They're spherical. They should look the same. The same number of electron, right? So the shell, the size is the same. Let me show you, okay? Someone can share me density formula. Density since primary school is what? Mass over volume. Very, very good. This formula, all three sciences use again, including bio have one. Don't forget your basic stuff. It's one of the most important. Okay? Okay. You realize they are all sphere. Well, I want to test people on max. Anyone max them good one? What is the volume of a sphere, i.e. a circle? For the fun of it. Disturb you. What is say? Power. Whoever say that. Volume of sphere means circle, okay? Is 4 over 3 pi r cube. You're supposed to know this. Okay? So the only unknown there, the change the variable is r, the radius. Yes? If you take a look at these two, the r going to be the same r because the number of shell they have is the same. Everyone okay? Why? Because electron number is the same. So r is the same. So the volume is the same. Can I put equal? So it didn't change. Everyone okay? So example 1 cm cube. Then, do you realize what I do? The mass number is different. Can see? This constitute the mass. So this versus this mass is bigger than this. Make sense? When mass go up and the volume never change, density must have increased. Simple mathematical formula. So ladies and gentlemen, it's all because of this. Physical property change. Why? Because the mass of the isotopes are different. Mass over volume. Look at the density. And density is a very important physical property of chemistry. Can isotopes, just understand, oh, there are 2 types, 3 types there, okay? Okay, I give you some more concrete example. This sodium I anyhow write out, the 22, 25 anyhow, right? You are interested, go in Google and find out how many isotopes there are. Okay, ladies and gentlemen, here we go, the formal introduction. Most elements, let's reach out nicely, right, are made up of isotopes. Only a few dozen exist. Let's take them as they all have isotopes. Take a look at your hydrogen. The hydrogen has 3 isotopes. And I'm going to use this example and it will be very clear. Okay? So hydrogen has 3 isotopes. Okay? So take a look at the periodic table first. Hydrogen from the periodic table, right? From periodic table is 1, 1. So no matter how I flip, it's still 1, 1. Everyone okay? Can I? Now remember, this periodic table is what value? Is a average of all 3 isotopes. Yes? Right? Average what? Here we go. The proton number will not change. Can you see? It's always 1 because this is hydrogen, is a characteristic of it. Make sense, everyone? There are 3 isotopes. Each of them has a different number here in pink. What is this number called? Be careful. It's called nucleon number or mass number. It's not called relative atomic mass. This is the part that in school they don't teach properly in a lot of places. Because sometimes the teacher also forgot about it, I think. Are you with me, everyone? It's the individual mass, individual nucleon number. Neutron is because of proton and neutron. Then what? All right, no space on, that's why I draw a line. But this one is different. This is an average. I'll use red color. This, in the periodic table, is known as your relative atomic mass. Everyone okay? It's like an average value. Make sense? Okay, so let me write out the three different ones, okay? So here we go. Number of protons, all of them must be 1. Yes. Number of electrons must also be 1 because they are all atoms, they are electrically neutral. What is the number of neutron? Is we take the pink minus the green. Am I okay? All right. So let me use a different color. So 1 minus 1, all right. Basically, sort this out, is equal to 0. Sort this out, equal to 1. Okay, I do the math for you. Okay. 1 minus 1 equals to 0. 2 minus 1 equals to 1. 3 minus 1 equals to 2. The number of neutrons are different. All the numbers we know very well. Proton number is the green color number. Nucleon number is the pink color number. How did we get in the periodic table that red color thing called relative atomic mass to be 1? Is by what? By taking average of all the nucleon number over here. Yes? Right? Which is 1, 2, 3. If I want you to comment, and it came out before these days, and you'll be like that. Can you comment, make a comment about this? How come the relative atomic mass in the periodic table for hydrogen is 1? What can you tell me? Comment means you can write, say anything. Comment. Why is it 1? Because here is 1, what? Here is 2, what? Here is 3, what? Take calculator, 1 plus 2 plus 3, average you divide by 3. Right? Tell me. 1 plus 2 plus 3 divided by 3. What's the number? 2, right? What can comment? I can comment on this. You see whether, why is it 1? IE is very close to this one, right? I think this is how they exist this way. The way they exist in terms of their abundance. You know what's abundance? English? How much is available? I will comment this. I'm very, very sure. Someone take calculator soon. I think most of them is this. And probably, not probably, most of them is this. And I think the other two, very low percentage. Someone, now you can take a calculator and press calculator. 98% times 1 plus 1 times 2 plus 1 times 3 divided by 100%. The average value, take a look. It is 1.000 something something. Which you round up, it becomes 1. Are you with me, everyone? So what's my comment? The comment is, I'm very sure, based on this, I think the first isotope, called the 1,1 isotope, should be of the highest percentage abundance, or the abundance. That's why in the periodic table, I saw the value 1, the average value. Like someone, okay, convince you. All right, so what is the, I figured it out, right? This is fake. Relative atomic mass of K, the symbol is AR, the mass, hydrogen, right? Someone has a calculator, 98% times 1, 98 times 1, plus 2 times 1, plus 3 times 1, okay? Percentage. Hey, come on, this is set 1, set 2 mathematics, percentage, right? Okay, divide by 100%, correct? To averaging. Okay, come. Someone has a calculator? What's the value? I'm very sure 1.000 something. Oh, not 1.03. Okay, so it's not that small. 1.03. 1.03 based on O-level periodic table, only 1, if not 2 decimal places. Yes? So it's 1.
If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.